So in this video, we're going to drop down to some more basics of programming. Now, it's not necessarily basics as, really simple stuff, but a lot of what we do in all these videos, a lot of you have started saying you're not quite sure what certain things are. One of the main confusions is between basically delegates, anonymous methods or anonymous functions, actions, functions themselves. So there's a lot of different ways to effectively invoke a method. So in this video, we're going to cover what a delegate is, what an anonymous method is, what a Lambda expression is, what an action and a func are, and go through them all. They're all basically the same thing. They all just invoke a method or are a method signature. So we'll step through them one at a time, and I'll simply explain exactly how they are. And then as you see me using them in the videos, it should make a lot more sense. So we'll first start off. Everything really starts with a delegate. You need to know what a delegate is first. So if we make one, that's the easiest way to show this. So a delegate is basically a variable that holds information about a method. So we can step back one more and do an actual method. So let's just make a method. Call it normal method. We'll take in, say, just an integer, and we'll return that integer times 2. So this is a normal looking method. The input value returns twice the input value. So there's just a normal method. I'm sure you all know what they are. If not, then you should go back to the very basic videos of C# that I've done. So there's a method that we can make use of. We also need to put a main method in this function so we can actually do something. So you could say var a, or rather var b equals normal method of, say, 2, so they should return 4. And if we run this code, we should get, the value 4 in b. So that's just a method in itself. That is just, how you call a method. So you should see now b is 4 there. So that's all fine. I'm sure you understand those parts. So that's invoking a normal method. Now, the main purpose of I guess the sole purpose of all the other things, Lambda functions, actions, normal functions, delegates, it's all aimed at being able to basically pass in a method as a variable to another method. So if we had, say, public static int another normal method, and we wanted to pass in this method itself as a variable like this, or we could even say run another method. This is, however you might want to do it. You can see you can't really do this. For one, you can return a value for now to stop that error, but that's basically saying you can't pass a method into another method. So the point of a delegate is to allow you to do that. So if we jump back to the top, a delegate is the definition of a method. So it's the return type, not necessarily the name. You can call it what you like. That's the variable name it becomes. So it's a return type and the input parameters, and that's basically your delegate. So if we make public delegate, and we'll make one to match this method. So it's going to return an integer, and then now the next thing is the name of, if we want to pass this type of method into a function, this is what you can consider the variable name of this delegate. So we'll call this manipulate. We could call it anything you like. This is the variable part of the name. And then in here, just like you're defining a method, it's going to expect an integer. So we'll say, int, and we'll also give it a name. So this defines a method that returns an int and has one int as an input. So by doing that, what this means now, we could have normal method delegate. And that can now be, we can make a new instance of the manipulate delegate as if it's a variable or a class, it loops the same way. And now it's expecting the actual, this is, a function, so this is expecting it to return an integer and pass in an integer. So we can actually pass it the normal method signature. So this now is a variable that we can pass into another function, and invoke, and it will point to this method. So the purpose of this delegate is to define a style of method to expect. So we're expecting a method that returns an int and accepts an int. And then when we create a new version of it, that's what it's going to ask for. Any method that returns an int and accepts an int. So it's allowing us to do that. So now create an instance of the delegate. And we should really put here, delegate defines the signature, return type, and parameters. So we know what that is. Normal method, create an instance of the delegate. And now what we can do is get the result. So you could say normal result equals, and you take the delegate. Let's presume this was passed into a function. We don't need to do that though. You got the delegate, and you can just open the brackets to call, if you will, the normal method. It will call the method that you passed in. So if we pass in, say, 3, what we should see is we hit here, and here, and then we'll get the result. If we didn't have build errors, we would. Oh yeah, that's because of this error here. So what you'll also notice here now, if another method wants to pass in this manipulate, or pass in a method of the same style, you can now use the manipulate as the variable. So you can pass a method in. So we'll do that in a moment. So we've hit normal method from that call. So that's just going to return there. And now this one is going to create a new instance of the normal method. It won't invoke it. It'll simply store it in this delegate that's now got access to the target, if you will. It knows where to go, this normal method. So it's going to expect when we invoke this, it's going to call this method, which it now does. And the input should be 3, which it is. And then our result will be 6. So the delegate's purpose is to define what a variable, what a method, its signature is, which is the return type and inputs. And the point of then doing that is so that you can now pass around methods to be called as if they're variables. So now we could just do, run another method and pass in the normal method delegate to get another result. So this would be pass the delegate as a variable. So if we run that one, you can now see we're able to pass in the delegate we created into another function that can then make use of that function and return the result, which didn't actually return the result because we, there's a point, run another method, because we returned 0. So we should actually then return the method, and then we obviously expect input. So we've passed in the method, but then we also need the value. So we'd say 4 in this case, and we'd have here the number to pass in, and we'd do such a thing like that. So this is just all, sample code to show you what the pointer is to be able to pass methods in. We're not doing anything special with them, but it shows that the ability of now being able to pass a method as a variable, if you will, chuck it around. So accepting method as an input. And then if we run this time we should get 8 because we've passed 4 in, and it boils down. So if we step in, you'll see it now run the method. It'll pass the 4 into the method. That'll jump into the normal method, and then that'll all bubble up and return to the 8. So that's the, this was a long time ago. I wouldn't know when, maybe C# 4, 5, 3, I don't know. It was a good while ago when you were able to create delegates to do this kind of thing. So natural progression then says, well, if I want to simply pass a method into a function to manipulate a value, in a set way, I don't want to have to necessarily always create a function like this and then have to define, a method in my class to just simply pass in a method. Quickness, basically. It's the same thing as not wanting to have to int a equals 1. Or a better example would be, say, a list of string a equals new list of string. And that's not dry anymore, it's repeating yourself. So that's why they introduce things like var, so it can interpret from the right hand side and you don't have to double up your code. So The same thing with the next phase, which is anonymous methods. It's simply always aimed at reducing that amount of code you have to write and code you have to type. So the next thing is an anonymous method. And that is basically a delegate that looks like this. And it returns a delegate. So to do an anonymous method, we can do, let's say, we will have to specify the type this time because an anonymous method doesn't return a type. That's the point, it's anonymous. You need to tell it what it should turn into. So we want to create, just like this, we're doing this exact line here. So we can actually copy and paste this for now. So you can see the, the changes. So we'll change this to anonymous method delegate. And now instead of having to do a new delegate of, that type, and then pass in the method to this function, well, we just simply want to say a times 2. And that's all you want to do. You don't want to have to define anything else. So first you can get rid of the whole new manipulate new method, and you can replace it with an inline anonymous method. So to do that, you have to start with delegate, the word delegate. In here is now your input, so I'll say int a, and then you open and close brackets like you're in a function. And now in here, so this is like you've done, normal method, if you will, open and close name. So if you want to visualize it like a method, all you've done is replace the name of the method with the word delegate, and then that now looks like a standard looking, it looks exactly like this part of the code. And in fact, you even put the return a equals 2 in there. So this is just a copy and paste of this part of code. You don't bother saying int as the return type because it's interpreted from the fact that you're returning in there, and you change that to the word delegate, and that's how a delegate looks. And now you'll see it's going to complain you can't assign an anonymous method to an implicit variable because it doesn't know what the whole point is. It's anonymous. It needs to know what you're expecting. So just like this is actually returning a manipulate delegate, an anonymous method returns a delegate. So we know it's going to be able to be a delegate because it's there. It simply needs to know the signature of what it's expected to return. So for that, we just say, well, we want it to be the manipulate signature. So these two lines are identical. And the only difference is now we've got a manipulate delegate, which simply says a function that returns int and passes in an int. And we can create that delegate now, that delegate here, using this anonymous method. So we tell it it's a delegate, we have an input of a, and then by doing return here, it's inferred from the fact that you've got an integer times by 2 that the return type is an integer. So this then satisfies the signature. If we were to say return true, then it's going to complain because the manipulate, or the complain there, cannot convert from Boolean to int, because this signature is expecting, an integer return value. So this is the anonymous method delegate done exactly the same there. If we copy and paste the result line, you can then do, say, anonymous result, and that's just invoked by calling the exact same thing. And now if we run this to confirm, we should get it returning 6 because it'll be calling that method. And then if you want to really see it actually calling that method, you can just plonk this on a new line, put a breakpoint in there, and you'll see it hit once we call the method. So it's not hit yet, we call the method, it goes in, returns the type, and gives us the result. So this was the first stage at improving quickness to, instantate or make use of delegates. So now you can just create a delegate, do what you want, and there you go. You have now a function as a variable that you can pass in without having to say it's now a new manipulate, and then it's this function now got to define this function out. It's not in line with your code either. So if this is very in line to doing some kind of calculation, you can see it right here, as opposed to it being jumping back and forward between methods. So they're the first 2 steps, which is delegates and anonymous methods. Now, again, you can reduce this more, and we want to also get rid of this delegate, the requirement for a delegate definition, because 90% of the time, well, in fact, all the time, it's basically a function that either returns a value or returns void, so it doesn't return, and accepts a certain number of inputs. So that moves us on to the next thing, which is a lambda expression. So lambda expressions, basically, in my definition, again, just this is what I haven't read anything up about them. I simply made use of them when they come out. I've experienced them and I've formed my own opinion of what I think the definition is. So you might want to read Microsoft's official documentation and, you know, if you're really keen about what words really mean. I'm one that just likes to do the code. I don't really care too much about the name. So my understanding of a lambda expression is basically anything that starts with that and a left-right value. So you'll see what I mean by that in a minute. Basically, they can return a delegate, which we've just seen and we know what it is now. So a method that can be invoked. Or, and this is something I won't cover in this video because it's a separate topic that I'd like to do, and it's a lot more advanced. Or you can return an expression of a delegate. So it can be compiled and then executed. So I will give you a brief explanation of an expression just so you're not left in the dark. Basically, an expression is, you can think of it as this anonymous delegate of a method is in itself the actual method, if you will. For the most part, it points to the method and you can invoke it like this, you can call it. An expression is another step back. It basically is a written explanation of what a method is in code, but then you can manipulate it in code. And then you can compile it into actual executable code and run it. And hence why I want to do another video on it, because it's not that simple to explain or to just state explicitly. But if we made it an expression instead, you could then say in code expression.properties.add boolean and then compile. And now you've changed the actual signature of a method. Or you could even change the return type and then execute it. So an expression is more of a, here's the input, here's a method, but now we can change it in code, manipulate it, and then run it as a different method. But I won't go into that in this video. We'll stick with just lambda expressions. Funnily enough, they're called lambda expressions, but as in the return type of delegate. So a lambda is, if we do manipulate again, we want a variable type. Just like an anonymous method, it's going to need to know the return type for now. So this is going to be a lambda delegate. And this is, again, basically you could think of it as a copy and paste of this. We just want to make a manipulate delegate. And just like the delegate A here, let's show you how it transcodes. So now with a lambda expression, which sometimes people think lambda expressions are called anonymous methods, and they're not. This is an anonymous method when you have delegate there. A lambda expression, you can now delete the word delegate. You can delete the brackets if you like. You don't need the brackets, now you just have A. You can delete the curly brackets and the return. You don't need those. And instead of those, you do what I was stating here, which is this special symbol. So here is your lambda expression, cut down as clean as you can get, as small as you can get. Got a little help there, use local function. What's that going to suggest? Int, yeah, so we don't need that. So this part's a lambda expression, basically, and it means you look for the the equals greater than. The left-hand side is then the return, well, not necessarily the return type, it's the inputs. And the right-hand side, if you don't specify curly braces, which you also can, you don't need to specify return. It's simply assumed that here's your inputs, and then this is your output. So same as this, there's your input, there's your output. So that's one way of doing a lambda expression. And that gives us, it returns a delegate, as we mentioned. So it's returned a delegate, and it's satisfying the manipulate delegate. It's passing in an integer, and it's returning the value. And we don't even specify the type. The type's been inferred from this. So we now have IntelliSense on the A as an integer because of this method. So this lambda expression is actually figuring out from the fact that it's been assigned to a manipulate that this is an integer. That's where the integers come from. So we've removed the requirement to specify the type here, when we know it must be a type based on what it's expected to return. So again, it's just further cleaning up. It's just removing every little bit of, bulk that we don't need, basically. So if we were to change this would break more than this, but In fact, let's just do manipulate 2 so I can show this. If we did Boolean, or let's say long, so it still kind of works, and we did manipulate 2 here, you should see now that A is a long, and now you can't convert when you times 2 longs together. It's going to give you a long number, and it's still expecting an integer to return. So you could change that to a long as well. But you can see now it's inferred from this delegate, and that's how it's working. So there's the lambda expression, again, as normal. Lambda result equals lambda delegate, just the same. Say passing 5, we can call this, and we should get 10 as the output. So there we are, that's the, again, yet another way to do. This is sort of this is what you'll see me doing a lot in code. In fact, a hell of a lot. So I'll do it slightly different as well. There's 2 ways to visually write a lambda. That's one, with nothing at all. Nicer way. So a nicer lambda is that you can put in your brackets around your parameters, inputs, so it looks a bit more like a function as well. And you can also do the function curly braces here. When you do that, though, you also have to then physically type return. And the point of needing to do that is because then once you put curly braces in, you break it out, it is a function. So you could say var a equals, or rather say var c equals 2, return c times a times 2. So as soon as you go from an inline single, statement that must be the return value, that's why you don't need the word return. As soon as you put curly braces in, you can now write a whole function in here. So it can't naturally infer what the return value is. You have to then type it like a regular function. So this is still exactly the same. I know it's now acting different because I've done that, but if we remove that, do that, this is exactly the same as this one. It's just a different visual way of writing it, and the fact that we've now put curly braces in means that we then have to specify return type, but now we're also free to make a more complicated function. So these are the exact same things. They're both lambda expressions, they're both returning a delegate. There is nothing different about that. And then if we just call that, and then we can see that will be 12 because it will call into that function. We could always pass the same number and change the values, but you can see what it's doing. So there's the 12. So these are lambdas. Now this is what I'm saying people often think is called an anonymous method. So they're like, yeah, I've just made an anonymous method here, or this anonymous method. This isn't. I know technically in a sense of the definition of the word, it looks anonymous and it returns a method in terms of a delegate, but this is the official, this is the older anonymous method. This was the first thing that was made. So delegates come first, I believe. Then, anonymous methods. Then you can do lambdas. And then the last part of this now. So this is really the cleanest, shortest way to define a variable to pass into a function, or a method to be able to pass into a function. But we're still left with this annoying variable here, that's manipulate in this delegate. So the final step of this is to remove that as well. And also just to quickly show you, lambda can return an expression. So as we mentioned, it can return an expression. Because we're having to tell it what type of thing it is, to return an expression, we just literally have to tell it to expect an expression of manipulate. And then we can just do the same signature. And there we have now an expression. And then from the expression, you can now do all kinds of things. You've got the body of the expression, the name, the parameters that are all editable. You can also then compile it, which will compile down to a delegate. So at this point, we're back down to manipulate delegate, and then you can invoke it as normal. You can just do that, or to make it look a bit nicer, you call invoke. But that's, like I say, another topic as the expression side of things. So now we want to remove this requirement for manipulate, and we just want to keep it super clean and be able to pass it in as a function. So the final thing is what's called actions and funcs, or action and functions, however you want to call them. And all an action is, so action is just another, well, rather is just a delegate. So we can do public delegate void, and we'll say my action. So this is now what we'd say is the action. And as you can see, it's just a delegate that returns nothing and has no input. So instead of having to define a delegate, a variable type, for a function that's simply going to execute and return nothing, we can do this, and then we could do var my function, or rather my action, and then we could make it with an anonymous method to do something. So var a equals 2. You don't need to do anything with it. It doesn't return any type. My action. So this is now just the same as all these other ones. You know, you've got your action delegate, and it's a function, a lambda function. So if you've got a lambda expression, you can't do this version when there's no inputs, because, you know, what's it going to do? It's going to look like that. So you have to put your blank brackets in. So that's how you do the action. Now the whole point, like I say, is to remove the need to do this. You know, to specify a type of return type, a type of delegate. So instead of doing my action for this specific one, there's already a built-in one, literally called action. So you don't need to define a delegate if it's returning nothing. You also don't need to define a delegate if it's returning nothing and also having inputs. You know, whatever the inputs are, it doesn't matter. So all of these things now, you know, can be, all this lot now doesn't have to be defined in this way. It can all be done via this action, built-in action, which you can see, you go to the signature, and as exactly as I say, it says a delegate void action. It's just a delegate, that's all it is, but it's now just simply built in, so you don't have to type it. So now when you want to run a, or rather create a variable of a method, of any signature really, you don't need to create delegates. There's rarely a case when you actually need to specify delegate. Now you can do an action. Or the alternate one is basically func is just a delegate with a return type. So again, if we were to do public delegate int my func, and then you can also pass in variables, but it makes, you know, that's optional and can be whatever we like. So this is all the func could end up being. So if we wanted then to do my func, you could then pass in, you could either do my func delegate that we've made, that's now expecting a return type. So we just return 2, or rather you don't need to return 2 if we're not doing the brackets. So now that's how we do a function that's expecting an integer. But like I said, instead of having to make these two things, this one's just now a func that's expecting a return type of int, and that's now the same thing. So we've used these special cases to get rid of the need for these two things here. So I'll leave those in just for visual, but now you don't need those. If we wanted to get rid of this manipulate, and we don't have to make that anymore, this is returning a type, so it's a function, and it's got one integer. So if we wanted to replace manipulate with our, you know, we didn't make that, say we didn't actually make that variable, and we wanted to do it another way, we could say replace manipulate with a func. So all you do there, replace this manipulate type func. It's got, you know, plenty of overloads to pass in a ton of variables, up to 16 inputs and 1 output, which you should never pass more than that into a variable, into a function anyway. At that point you should create a class with the values in. So we have an input and then an output. So the input is an integer, the output's also an integer. And now we have a func delegate. And as normal, func result is then the func delegate. So now you can see, even though we have to type this, you know, it is, it's auto-created for us, you know, so we've got rid of the need to actually create the manipulate delegate in our code, we don't have to do this now. We don't have to do these. So all of them could technically be deleted, and you can make use of them. I think, if I remember rightly, you can also do, so it looks cleaner, do a variable. Oh, let's try this. Func to delegate. And in the Lambda expression, I believe you can pass in the expected types. And maybe not. You cannot assign Lambda expression to implicit. No, so you can't do that. You still have to always, specify the type at least. So that is where we're up to with actions and functions. So let's clean this up. An action is just a delegate with no input and no return type. And that's how you would do it. An action, my action, or we call it action delegate. And it just does something. So that's fine. And then it's complaining because it's not used, but that's because this is just sample code. Then a function, or in this case a func specifically, because we're talking about the exact variable types. A func is just a delegate with a return type. In fact, that isn't right either. No input. With no return type and optional input. Because, as mentioned, if you want to have an action that has input, we could do action that's going to expect an integer. I'll call that action 2. And this is now going to expect an input of a. So now var b equals a times 2. Just do something with that value. And what are you complaining about? A local name b, it's already used in the scope. I must use b somewhere else. So the other thing when you are doing inline things like this, you can make use inside of here of the stuff outside. So a really useful thing here, say this action delegate, we can actually make use of, say, this Lambda delegate here. We can make use of it inside our... Oh, no, we can't. Oh, yeah, we can. Lambda delegate. There we go. I thought we could. So we can now call inside of this delegate a delegate that we've just defined in this scope. So that's the benefit of doing inline as well. So this complaint here about b, it's because we must have b already defined there at the very top. We called this method b. So normal method invoke. Result. So now we can do b there. So you just have to be aware of when you're doing this kind of layout. Not sure why that's gone. That colour, that's weird. Oh, that is weird. I've never seen that colouring before. Don't know what that is. That's interesting. Anyway, I want to play with this now. What's that doing? I have no idea why that's gone brown. Somebody might know that and can inform me. I've got no idea why this thing's turned brown. So yeah, you've got your action that you can invoke a method, do what you like. You can then also create an action that accepts an integer as an input or whatever as an input. You can change it to whatever you like. You can have a string, int, boolean, and then you could have my string, my int, my bool, and then you could say, you've got access to them there. There's a boolean, there's an integer, there's a string. So, there's all those ways of defining it, but bottom line is you should not have to now make... Oh, I know why it's gone brown. It's because I've got the search open up here. Mystery solved. So you don't have to ever define a delegate. There's a rare case now you'll ever have to do this. So you can simply pass it in. You don't have to do delegate anymore. You don't have to do return types because you can move to lambdas. So it all becomes a lot cleaner. And, you're down to doing it this small and simple. Now, let's say we wanted to put it in a bit more of a real-world scenario. Let's make a class. So we'll do a public static class. Just call it helpers for now. Public static string. And what we'll do is we'll mimic the link expression we use a lot, which is, say, get first or default or where or list. All the Lambda expressions we use, the link expressions. So let's say get first or default, which is an actual, it is a thing. And in this, we will pass in, we'll do this, so it's an extension method, so we can just call the variable and then dot. So I'll show you what this does in a minute. a list of, say, strings, items. So there's the input that we want to find the first or default, and then we now want the action to actually find the first or default. That's how it works. So in this case, now we'll expect a function with an input of a string, because we're going to pass it each item string, and we want to return whether it's matched or not. So it's going to return Boolean. We'll call this find match. So now in this function here, we can do for each var item in items. So we'll look through each item, and then for each one, we can say if find match, and we pass in the item itself, the string, and it's going to return a Boolean. So if this function that we will pass into this function, if this accepts the string and decides that it's the one it wants, it's matching, it's going to return true, then we will return that item because we're expecting to return, the item. If it gets all the way to the end and nothing's found, you return null, say, because first or default would be expected to return null as opposed crash. So this kind of mimics what the first or default would do. If we then come up here and mimic the first or default link expression, we would then do, first let's create some items. So a new list of string, new array, and in here we'll just have, say, A, B, C, D, F, and G. So that's just a list of items. Now what we typically do is we'd say items.first or default. And if we did first or default and added the link expression, so this is the original one, not ours, you can see it's expecting exactly what we've passed in, a function that accepts a string and returns a Boolean, and they're calling it a predicate. So this is exactly the same as our signature. In fact, we should be able to F12 into it. You'll see that this will be anonymous. This will be generic rather, but same thing. So it's like this one here. So it's returning a string that we've passed in. It's got a list, in this case not enumerable, of string. Then that'll still be string. So it's that signature there that basically matches. So the way you'd call that would then be it's expecting now. And you can see this is now expecting a function of a string and a Boolean. Well, we've seen how we make them, because, for example, there's a function of an int. So this is how you make them, just a Lambda expression. So whenever you see in here that it's expecting a func, all you need to bear in mind is the last one is always the return type in a func. So it's expecting to return a Boolean, and you got one input of string. So you need to create a, let's say we do it on a separate line so it's super clear. So it's expecting a string that returns a Boolean. We'll call it AA for now. So this would be my string, or in this case what we're going to call it item, because you can call that anything. And we'll say return if the item equals C. And I know it's a string and you should do string dot equals or anything else, but this is just an example. So there we've defined a method that's just literally going to say, and again, if you want this to visually look clearer, you could do item. I think you can also explicitly state, that it's a string, just for clarity, if you want to really visually see it. And then you can turn it into the function style of a Lambda expression. So you can do it that way, so it's just visually easier to see initially. Now you've boiled this down to simply being a method. So again, if you really want to go to visualizing it, it would just be a function that returns a Boolean that's called, say, does match. It accepts a string called item, and we say return item equals C. So all we're doing is ultimately making a function like this that says does match this item, does the item equal C. As we mentioned as we went through this video, though, as you step down these progressive stages, you'll see that you don't need the method itself, does match, because you can use delegate. So for that, you'd just delete, this part, and you'd have, a Boolean, or rather, not in that, you'd delete this part. You got an item string, and then you return. You simply step down what we've done through the video, and you'll boil down to this being your Lambda expression, delegate, if you will. You can get rid of that then because you know it's a string, it's implied. Get rid of those braces, you don't need them. And because we're doing a single line return, you get rid of that. And that's where you boil down to this statement. So then when you see me doing statements like this, you can see that by looking, you've spotted this. So you go out to Lambda expression. So the left side is inputs, which means we've got a single input called item. And the right side with no curly braces means the statement itself should return. It's a natural returnable statement, so it ends in a result. So by doing item equals C, the result is a Boolean. So this becomes, you know, a function that has an input of string and returns a Boolean. You could then pass this in now to first or default, the original call, and say found item equals first or default AA. And if we run this, it should loop this list and it should return that C instance. So we've got items with 7 things in. And when we call found items, it's going to call first or default, and it's found C. And then again, if you want to see it actually happening, just simply break this out to a function, put a breakpoint in, and then run it again. And when you hit the first or default, now you can see it's iterating over. So first item A, does it match? No. So it's going to call again, B, no. It's going to call again, C, and then it's found and it returns. So that's making use of a function, a Lambda expression. You can also then reduce this further than you typically do, because then this is how you get rid of this finally. You now just take the actual statement, let's boil it back down to its smallest part. Here's a statement. You now cut that entire statement and you pass it straight into the function. So now you end up with a super clean looking single line of code that gives you the first item. And that is, you know, this is where the real benefits of the whole Lambda expressions come in. You're now down to these one-liners. But hopefully now this will make a lot more sense to, you know, what I write when I write things like this. And you can kind of tell that what we're doing, we're expecting an item out of here, and if the item matches, but you're not quite sure what the left-hand side is, what the right-hand side is, do the names matter, why sometimes I do the curly brackets and sometimes I don't. So now hopefully this will clear up all that mess. So this is calling the built-in link first or default. And you'll now see, in order to, if you wanted to make your own functions like this, you can now call our method. So to call our method, we can do the found item, just call it found item 2. And this time we should have get first or default here, and that's our method. And the reason we can do, you know, items dot get first is simply because this is an extension method. So an extension method has to reside inside of a static class. That's why we made this static. And the method itself has to be static. And then the first parameter, I don't know whether it has to be the first actually. I don't think it has to be the first. No, it doesn't have to be the, oh, maybe it does. Has a parameter modified this, which is not on the, yeah. So this always has to be on the first parameter. And by doing this, all it means is instead of doing here, which you'd expect, helpers.get first or default, items and then whatever, you can now replace, you can move the first item to the start of the method and call it directly without the namespace and without the class name. So it's a way that it knows if for any variable that's of this type, when you press dot on any variable of that type, you should be presented with this method. It's just a quicker way of invoking it. So that's all that extension method is. So we invoke our method called get first or default. And then you'll see ours will accept the exact same function here. So we can now call the same thing as the default one, and you can see us actually doing that. So we've got a bunch of strings, we pass in this Lambda expression here. So we go in, you can see we've now got a match. That's our expression we just passed in. And we've got the bunch of items. So we'll look through each item, which is A. Then we'll call find match, and this will actually now call into this method here, which will do exactly the same check. So that's now running there, and it'll loop through until it finds it, and then it'll return it just the same. So that's making use, and this is like a real world use. This is what you do and what I do a lot, where you pass in, you're expecting functions to run, so you can do certain things. So that's like I'd say a real world example. If you wanted to go further down and make this more like the original, just for the sake, you can do generic classes, which I think I've done a video on generic classes already. So you could change this to say tResult, which is just a name we've given. And if you put the angle brackets here, this means now this is a variable input, so it can be any type at all. You replace the input of the values coming in and the return type with it. Basically, you replace everywhere that said string with tResult, and you're expecting this result to be passed in via the method. Now, you can't return null on an unknown item. So what you can do instead is return the default of the item itself, which is, a default of then string, which is then null. And now you have a method where you could have a bunch of strings, you could have a bunch of ints, item ints, and this could be, in fact, we can cheat there and just do enumerable.range 1 to 10 to list. That's a lot quicker way of doing that one. So that's still just a list of numbers, but now it's filled with 1 to 10. And we could also call our same method, but this time with integers. So if we passed in item ints, it would get that and it'll also return. And now this is going to say naturally change because it knows that the items is integers. So it knows now the input is an integer. So now it's expecting, say, item is greater than 4. So now it should return 5. And that's the exact same call now. So this will now handle strings and integers. So now what we've done is broken out the logic of, we have a list of items that we want to pick the first one that matches a certain predicate. And that's kind of the point there. So now with the exact same method and all this logic about, the logic's the same, whether it's a string, an integer, or anything else. If you want to find the first item that matches something, you always want the items, you always want the thing that's going to find the match, you always want to loop the items, you always want to try and find the match and return it, and if you don't, you want to return the default. So this logic here now is reusable. And the variable of matching a specific type of item is passed up to the caller, and then they can simply pass in the smallest bit of code that does that check, and that's where you get all these kind of benefits. So we're going past the point of the video there, though, but hopefully this is cleared up what delegates are, which is the signature of a method, so the return type and the inputs. Anonymous methods, which are this style, delegate, open, close, which are now, there's never a point to use these, by the way. There's never ever a reason anymore to need to use anonymous methods. They're there to show you, how it was done. Then we now know what a delegate is, but again, you should rarely ever have to actually make a delegate, because you can now use actions and functions like, this func and action. Not like this. I've made this just to show you what they effectively are. And then you've also seen using Lambda expressions to create those delegate actions and functions. Both styles of simply, the cleanest one or the smallest one, and then the more expandable one. And like I say, the more explicit if you really wanted to, and, passing in types just to visually see it more. And that should have cleared up, what is the difference and the change between delegates, anonymous functions, actions. All of them are, like I say, ultimately the same thing for the most part. Obviously, delegates are the signature of the other things, and then the anonymous methods, the actions, the functions are all the same thing. Ultimately, they boil down to running a method. So hopefully that's cleared up, what these are, and now future videos, you might have been just simply looking at them and knowing what they're doing, but not fully understanding. Hopefully now it's really clear, and you can start making use of these yourself. And once you start using them, you never go back. You'll see how much of my code is one-liners of, functions, actions, all combined together. So they're really, really useful for nice, clean, and easy to interpret code. As usual, any comments, questions, just let me know, and I'll get back to you.